In this video, we'll be looking at the first example of defining the focus and the directrix of a parabola given the equation, and then sketching that parabola from that information. So in this equation, we should be able to actually look at this and go, well, we've seen this equation before. We know what it's supposed to look like. The question then comes around of how do we find the focus and how do we find the directrix? Well, when we look at this equation, what we're first going to do is we're going to attempt to get it into the form of something along the lines of x minus h quantity squared equals to 4p times y minus k. Now, in this equation, which we'll fill in the next video in the box below, is that h and k are actually the vertex. Now, in this case, since there's nothing added to y or nothing added to x inside the squared, we can argue that this vertex is going to be at 0, 0. So that means that when I go to graph this thing or sketch it, I'm going to go ahead and do that over here. I know that my original starting point of this graph is going to sit right there. Now, with there being a negative 1/2 multiplied by that x squared, I know that this is a parabola that's supposed to face down, meaning it opens up in the negative direction, okay? But I still need to know where the focus is, and I still need to know where the directrix is. So I can sketch this, but it's not going to be accurate to what I'm looking at. So it's better for me to identify first what the focus and the directrix are, and then attempt to sketch the graph around those. So how do we find the directrix and how do we find the focus? Well, that p value seems like it's a very arbitrary, just selected value. It's not actually arbitrary, it's really, really specific. If this is my vertex, h comma k, then I can very easily find my focus by identifying specifically this is the way I'm going to phrase this, 4p sits with the y value, so the p, which is the distance from the vertex to the focus, and the distance from the vertex to the directrix, you're going to take that p value and add it to the y value of your vertex to determine exactly where your focus sits. Again, you're going to add it. Now, p, keep in mind, could be positive or negative, and in this case, I'll be able to solve for that p value, which I will do so. The focus is supposed to be, again, h comma k plus p, while the directrix, again, keep in mind that the directrix is simply a line that goes in the exact opposite direction of the focus, is going to be some form of a y equals. It's a line. Make sure that you denote it as a y equals, and in this case, it'll be k instead of plus p minus p. So all we have to really figure out how to do is how do we solve for p in this equation? Well, given that I'm going to have some form of a negative 1/2 times x squared, I should really be moving this term over. By moving this term over, it's going to provide me with my, again, 4p times my y term, while my x term is the squared term. So let me go ahead and do that. I'm going to go ahead and manipulate this equation. I'm going to multiply both sides by a negative 2. So I'm going to have a x squared equals to a negative 2 multiplied by y. Now, again, it's important to note that there's no plus or minuses here. There's no plus or minuses here. So my h comma k, which is my vertex, is 0, 0. So I'm going to note that over here in a capital V 0, 0. I like to abbreviate my vertex as V, my focus as F, and my directrix as D. Those are perfectly fine to do so in terms of asking for these problems. Now, I know again that my vertex is 0, 0. I got to figure out what my p value is, because my p value will define what the distance is, again, from the vertex to my focus, as well as from the vertex to my directrix. So to do that, I know that since this is all being multiplied by y minus k, this whole thing is technically that same exact thing. So in that case, 4p is supposed to be equal to negative 2, which tells me that if I solve for p, I'm dividing by 4, I actually get a negative 1/2. So this p value tells me what the actual distance change between the vertex and the focus. So that means that what I'm technically doing is I'm moving a negative 1/2 unit from my vertex. Again, keep in mind, this should make sense. With the x squared, this should be facing down. So if this unit right here is 1, negative 1/2 is right there, that's where my focus should be. Negative 1/2 unit in the y direction. If I want to find my directrix, again, keep in mind, if that's 1 full unit, my directrix is 1/2 unit in the opposite direction of the of the focus from the vertex. So that means that if I do this correctly, I'm going to add the negative 1/2 to the 0 in the vertex to find my focus. So I get negative 1/2 as a y value of my focus. And then to find my directrix, I'm going to subtract that value from 0. So it's 0 minus a negative 1/2, which is why you end up with y equals a positive 1/2 for that equation. So there's the 3 key details of solving for a parabola in terms of all the information. Keep in mind, if it asks for the axis of symmetry, which I'll go ahead and AOS, the axis of symmetry is actually going to be the line that passes through the x coordinate. So x equals 0 in this case. Again, notice x equals 0 is the dotted line that faces this way. Now, to sketch the graph, again, we should have the directrix identified as well as labeled. We should have the focus identified as well as labeled for what it really is. And then we should just simply graph the parabola, again, surrounding the focus. It should be curving around the focus. Now, this doesn't have to be viciously accurate. That's why it says it's a sketch. But I do need to see the directrix as well as the focus when graphing these things, so it's clear that you guys understand what's going on. So this is the equation as well as the write-up of how to do this entire problem. We'll be filling in these details in the next video, in the next box.